So these are our factors versus roots notes. You already have the PDF copy uploaded, so you can follow along with me. So we've already talked about factoring quadratics. That's what we spent last week working on. That's when we have two polynomial statements, which are usually binomials. So like x plus 1 times x minus 3, for example. And then when we multiply those together, we get back to our original quadratic. So the reason that factors and roots are different is that a root or a zero is the value of x that turns our entire quadratic equation output or y value to 0. So what we're doing is finding the x values of the x-intercepts. So if you are a graphical kind of person, I'm going to switch over to Desmos here. What we're looking for when we factor a quadratic is this point and this point. So for example, this quadratic equation has roots at -2 and +4 because those are our x-intercepts. So what we're finding, just to document this on your notes, is we're finding these x values here. And what we're going to use is the zero product rule. So if two things are multiplied together, A times B or whatever it might be, one of them has to be 0 or they both are 0. That's just how multiplication works. If one thing I'm multiplying by is 0, the whole thing turns out to be 0. So we're going to use that property of multiplication while we solve for these roots. So we have a couple examples we're going to work through together. So the first thing we have to do is factor our quadratic. Everything we've done so far in factoring comes into play. I still have to look for a greatest common factor. I still have to look at if it's a perfect square or not. Everything we've done up to this point, levels 1 and 2, both apply. So after I do that, I'm going to walk you through steps 2 and 3 so that you understand what I mean by steps 2 and 3. So we're starting out with just a level 1. I have an a value of 1. So that tells me I'm breaking down 12 to make 7. So I'm multiplying to make 12. So ways that I can multiply to make 12, I have 6 times 2, I have 4 times 3, and I have 12 times 1. Everything is positive because both of these are positive. So I'm going to add to make 7. So 6 plus 2 gives me 8. 4 plus 3 gives me 7. So that's where we're at. So this corner is going to be x squared, and this corner is going to be 12. Then I have 4x and 3x. This is just factoring. So this way they have x in common and 3. Across the top, I will have x in common and 4. So my factors are x plus 3 times x plus 4. So that, nothing is different from what we've done before. What we're going to do next is where things get a little different. So I'm going to take both of my factors, x plus 3 and x plus 4, and I'm going to set each factor equal to 0 because it is possible that this set of parentheses is the thing that turns out to be 0, or this set of parentheses is the thing that turns out to be 0. So I'm going to take x plus 3 and set that equal to 0. And I'm going to take x plus 4 and set that equal to 0. So solving for x, I would subtract 3 from both sides. So this would say x is equal to negative 3. I would do the same thing over here, minus 4 from both sides. So x equals negative 4. So my roots are x equals negative 3 and x equals negative 4. This means that if I substitute negative 3 for x back into my original equation up here, my answer will turn out to be 0. Or if I substitute negative 4 into my original equation up here for x, my output will turn out to be 0. So if I looked at the graph, it would cross the x-axis at negative 3 and negative 4. So the next example, we've got x squared minus x minus 12. So we're going to go ahead and multiply to make negative 12. And the only reason I'm not doing anything else is because technically this is a 1. So I did 1 times 12, negative 12, which still gives me negative 12. Since I'm adding to make a negative value, as I'm listing my factors of 12, 1, the larger number has to be negative. So it would be negative 6, negative 4, and negative 12. So then when I add to make negative 1, negative 6 plus 2 makes negative 4. Negative 4 plus 3 makes negative 1. So there's my 2 other pieces for the box. So this will be x squared, and this will be negative 12. And then I've got negative 4x and 3x. So now I'm working on finding common factors. These are still both going to be x. This will be positive 3, and this will be negative 4. So my factors are x plus 3 and x minus 4. And I'm going to set both of those things equal to 0. So x plus 3 might be the thing that's 0, or x minus 4 might be the thing that's 0. And I'm going to solve for x. This is the same as before. This time I'm adding 4 to both sides. So my roots are x equals negative 3 and x equals positive 4. So last but not least, we've got one more. Now this one is going to cover 2 bases at once, because the first thing I always do is look for a common factor, and 4 and 16 are both divisible by 4. So the first thing I'm going to do is divide both of these by 4. And then whatever's left over is going to go inside of the parentheses. So that divided by 4 leaves me with x squared. Negative 16 divided by 4 leaves me with negative 4. I still have a perfect square factoring here because technically there's a coefficient of 1 here. 1 times 1 gives me 1. And here 4 we know is 2 times 2. So I can split this into x and x, and I can split this into negative 2 and positive 2. So that's going to turn out to be 4 times x plus 2 times x minus 2. There will be times when I have a greatest common factor that I need to deal with first, which will go outside of the parentheses, like we've done in all of our other factoring questions we've done up to this point. The only time I worry about dealing with setting this factor equal to 0 is if it has a variable attached. And since we didn't look at one like that, I'm going to add one more into this after this example. But since this is just 4, there is no way that this number can affect my multiplication turning into 0 because 4 cannot be 0. So I only need to deal with x plus 2 being equal to 0 and x minus 2 being equal to 0. So then I would subtract 2. So I'll have x equals negative 2. And here I'll have x equals positive 2. So here my roots are x equals negative 2 and x equals positive 2. But just so that you can see what I mean, I'm going to add an example 4. Let's say I had 8x squared plus 12x, just for an example. So out of both of these things, I'm going to be able to factor out an x because they both have an x. But I could also take out a 4 from each of these things because 8 and 12 are both divisible by 4. So what would get me back to 8x squared through multiplication? Well, that would be 2x. And if I divide 4x out of this, the only thing that's going to be left over is a 3. So when I write this as a factor, I've got 4x on the outside and then 2x plus 3 in parentheses. So I'm going to take now this factor and set it equal to 0 because there is an x, and this x can affect what happens with my multiplication. So 4x equals 0 or 2x plus 3 equals 0. Well, the only way that I could ever multiply with 4 and some number and make it equal to 0 is if that number itself was 0. So x could be 0. Or I would subtract 3. I don't really need that yet. So I have 2x equals negative 3, and then I'm going to divide by 2. And oh yeah, by the way, it's possible that you could get fractions for answers. So I could have x equals 0, or I could have x equal to negative 3/2. One thing I will tell you, as you're looking at the practice questions, it is possible that you could see something like 2n squared plus 3n equals 9. You can't do anything with these until all of your terms are together on the same side and 0 is by itself. It has to be equal to 0. So I'm going to subtract 9. So I would see 2n squared plus 3n minus 9 equals 0. And now since I have equals 0, I'm good to start factoring that. Not every question is going to require some manipulation of your original quadratic, but some of them will. If you have any questions or concerns, or you feel a little confused, you're more than welcome to email me or send me a message. But as long as you're okay factoring, it's not that much more of a leap to get your roots.